Archaeology is a wide and varied discipline, with numerous methods of laboratory analysis available to be utilised. XRF, or X-Ray Fluorescence, is probably one of the more well-established methods. Now, there are a variety of different XRF machines, from big ones such as this one, to suitcase-sized to even small ones you can hold in your hand. But these all do the same thing: to non-destructively measure the concentration of elements in a sample, whether this be a fine powder or an artifact. But how exactly does it do this? Well, inside each object is a series of atoms. As I'm sure you know, an atom is comprised of a nucleus made up of protons and neutrons, and this nucleus is surrounded by electrons. And typically, the amount of electrons is equal to the amount of protons. Electrons are organised into a series of shells. Each shell has its own level of energy. The further away from the nucleus, the higher the energy of the electron. To determine what element is in a sample, the XRF machine fires an X-ray photon at one of the inner electrons, knocking it out of orbit. This causes the atom to become unstable. To fix this, an electron from one of the outer shells moves in to replace the one in the inner shell. But remember, the outer shells have a higher energy than the inner shells. In order to get from the outer to the inner, it needs to lower its charge. To do so, it releases what we call characteristic energy, which is unique to each element. It's this energy that the XRF machine measures. But what's the practical use of this in archaeology? Now, XRF can measure the composition of an ancient coin, how a piece of pottery was fired and glazed, or even discover what type of ink is used on a piece of parchment. But XRF can go even further back, and be applied to Neolithic artifacts that you might not even expect. A team of archaeologists from the University of Calabria in Italy utilised XRF in their studies of Neolithic obsidian artifacts. The team created a baseline XRF database of obsidian deposits throughout all the Mediterranean area that would have been accessible during the Neolithic period. Since then, they've analysed over 2,000 different archaeological obsidian fragments, linking 95% of them to their original source. So, what does this mean exactly? How can we utilise this information? Well, say for example, there's a fragment in Greece which originated in Italy. This could be evidence of trade, migration, or even conflict. Now, while this all may seem fantastic, there are some things that XRF simply can't handle. It's mostly limited to these elements here, anything higher or lower on the periodic table, and it has a hard time reading the concentration. But nevertheless, as you can see, XRF is a fantastic laboratory technique. From its relative portability, low cost, and non-destructiveness, it is a welcome method in any archaeologist's arsenal.